project came about because we outgrew the capacity of our previous building. We just didn't have the room to fit everybody in. This plot of land had originally been set aside for a convention center, but was never developed. And it really made sense, the ability to expand down the road 20, 30, 40 years from now. We started looking for a partner that would understand our vision. Bird and Next were very straightforward. It was a very open process, a very consultative process. We were involved at the design level quite extensively. I was spending a day a week at the Next office, answering questions, participating in the design meetings, providing input from the owner's side.
This project was an opportunity to really do things differently. On a project of this size, 80% of the risk sits with what we call the Fab Four: the structure, mechanical, electrical, and building envelope that includes the architectural. To drive that risk down, what we did was conduct weekly SLAM sessions, a success level assessment model. Focus on the big issues around risk, lock it in place, and then move on to the next piece of risk. And sometimes non-linearity is involved. You have to do things that you want at the end, you have to bring them forward. What made this distinctly different is instead of the insanity of going from 3D to a 2D, and then back up to a 3D, and then down to 2D, and then back up to 3D, we said, let's just see if we can eliminate a lot of the drawings. They weren't primary, they were secondary. And in that way, we went 3D, 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 file, fabrication, field.
The AUPE model had over 380,000 unique elements. And as we progressed from a lower LOD to a higher LOD and moved into the pre-construction phase, we had to split that model out due to the limitations of the technology. The models were brought back together as a fidelity model. It was so well done that once the construction team took over, they used the model as a quality control rather than a clash detection.
We had to create the structure to work with the very complex form of the building and collaborate with the next architectural team. Then we end up with the very simple column configuration that helped to advance the design while the architectural, mechanical, electrical design were still being developed.
We integrated software which enhanced team efficiency and essentially eliminated RFIs and changes. We had very few structural design changes, which is remarkable in a project of this size.
Consider that this floating stair is hanging from the floor that is hanging from the roof. So the construction sequencing and detailing was very complicated and required significant collaboration.
Coordinating these hangers so that they could work with the expected deflection so that they leveled out at the right time in the construction process.
I think everything came together using right technology in the right time and high level of effective collaboration.